This lesson is on inverse functions. Inverse functions undo each other. There are several inverses that you're very familiar with, such as addition and subtraction, multiplication and division, squares and square roots. Today we're going to learn how to find the inverse of an entire function. So let's take a look at our visual here. Here is what inverse functions do to each other. You take an input, drop it into the original function. The output is f of x. It's some sort of y value, part of our range. You take that output, and now it becomes the input for the inverse function. When you compose a function with its inverse, the output is what you started with. A little note here about the ordered pairs for each function. Notice on the first function, our input was x. That's what we dropped into the function, so that's the x value. The output is f of x, so that's our y value. However, for the inverse function, those switched. The input was f of x, that's what we dropped into the inverse function, so that becomes our x value. The output was x, that becomes our y value in the ordered pair. So notice that the ordered pair switched. The x and the y values switched for the ordered pair. Final vocab term is horizontal line test. You're all very familiar with the vertical line test to see whether or not a graph is a function. A horizontal line test tells us whether the inverse will be a function. One more note, the graph will still have an inverse if it fails the horizontal line test. It's just not a function. Our 1.8 lesson on inverse functions, the essential question is, how are inverse functions useful? Starting off with relations, and we will check to see whether or not it is also a function. First of all, we look for the x value. If any of those x values repeat, it is not a function. In this case, all of our x values are unique, so yes, this is a function. For the inverse, remember what we saw on that vocab page. The x and the y values switch to get the ordered pairs for the inverse. So notice I took those original ordered pairs and switched them around. All of the x values became y's and all of the y values became x's. Is the inverse a function? Checking the x values this time, they are all still unique. So yes, we do have a function. And now we'll plot the points for both the original function as well as the inverse. The original function I'll plot in purple. So we had the ordered pair 1, 2, 2, 4, 3, 6, and 4, 8. The inverse I'll plot in blue. We had 2, 1, 4, 2, 6, 3, and 8, 4. What I want you to notice graphically about a function and its inverse is that they are reflected across the line y equals x. Next, we're testing to see if this graph has an inverse that is also a function. So we'll use the horizontal line test. Can we place any horizontal line on this graph that touches it more than once? The answer is yes, so the inverse is not a function. Remember, it still has an inverse, it's just not a function. Part B, if we took a horizontal line and slid it from the bottom to the top of this graph, it would touch the line only once in every place, so the inverse is a function. In the next video, we'll look at how to write the equation of inverses.